Good morning, ninth standard children. We discussed about previous class matter around us, classification of matter, what is meant by element, how many elements present in the atmosphere, and what is meant by atom and molecules, and what is meant by compound, how to divided into elements, metal, non-metal, metallites, and what are the difference between elements and compounds, what are the difference between compound and mixtures. These are the things we discussed about in previous class. Yes, okay, now we discussed about types of mixtures. Okay, what is meant by mixture? Already I taught in previous class what is meant by mixture. A mixture is a impure substance. A mixture is a impure substance. Mixture contain two or more kinds of elements or compounds are both physically mixed together by any ratio. That is called mixture. For example, lemon juice, sugar and water. These are the things we discussed previous class. Now we discussed about types of mixtures. What are the types of mixtures? Okay, listen. Most of the substance that we use in our daily life are mixtures. Yes or no? We are using most of the mixtures. Okay, some mixtures we will able to see the components with our naked eyes. Okay, components there in mixtures having different types of components. Okay, so you see that components with your eyes, but in most others the different components are not visible. In a mixture some components are visible. You see that components in your naked eyes, but most of the components are not visible. Okay, these two difference is based on the mixture can be classified two types. What are the types? First one, homogeneous mixtures and heterogeneous mixtures. Okay, the homogeneous mixtures is divided into two types: true solution alloys. Then heterogeneous mixtures is divided into two types: suspensions colloids. Okay, now we see this topic: homogeneous, heterogeneous mixtures. Okay, first, a mixture in which the components cannot be, listen, the components cannot be seen separately. Seen separately is called homogeneous mixtures. In homogeneous mixtures, the components is not visible. Okay, the components is not visible. Okay, that is called homogeneous mixtures. Okay, listen. It has a uniform composition and every part of the mixture has the same properties. Okay, it has a uniform composition. Okay, many components are present in the mixture. That components have uniform composition. Okay, every part of the mixture has the same properties. Okay, tap water, milk, air, ice cream, sugar syrup, ink, steel, bronze and salt solution. These are the mixtures or homogeneous mixtures. Listen, homogeneous mixtures means it does not see your naked eye. It has uniform composition. It has same properties. Okay. For example, tap water, milk, air, ice cream, sugar, syrup, ink, steel, bronze and salt solution. These are the things are homogeneous mixtures. Okay. Then next one, a mixture in which component can be seen separately. Listen. A mixture in which components can be seen separately. It is called heterogeneous mixtures. Okay, what is meant by homogeneous mixtures? The homogeneous mixture cannot be seen separately. The components cannot be seen separately. In a heterogeneous mixtures, you see the components with your naked eye. Okay, it does not have a uniform composition. It does not have a uniform composition. It does not have a uniform composition and properties. For example, soil, a mixture of iodine and common salt, a mixture of sugar and sand, a mixture of oil and water. Listen. First example, soil, a mixture of soil, iodine, common salt, a mixture of sugar and sand, a mixture of oil and water, a mixture of sulfur and iron fillings, a mixture of milk and cereals. So these are heterogeneous mixtures. Okay. For example, you see mixture of oil and water. You see the oil in a mixture. Yes, oil and mixture. Yes, you see the mixture of oil and water. You see your naked eye. So these mixture are called heterogeneous mixtures. And then second example, you see another one example, sugar, mixture of sugar and sand. You see separately sugar and sand. Okay, so these called heterogeneous mixture. Heterogeneous mixtures means you see the component with your naked eye. Okay, okay. Next, listen, see this figure, homogeneous and heterogeneous mixtures. Okay, homogeneous and heterogeneous mixtures. A is a homogeneous mixtures. A is a homogeneous mixtures. You see any components or see your naked eye? You didn't see the component with your naked eye. So this is homogeneous mixtures. And second one, B. You listen. You see the components. Yes, you see the components. Some milk are having and some vegetables are having. Some rounds. Okay. So you see your naked eye. Yes. So these components are called heterogeneous mixtures. Okay. Okay. Next, listen. Separation of mixtures. Separation of mixtures. In a mixtures having many components, how to separate the mixtures? Okay, many mixtures contain useful substances mixed with unwanted material. Okay, unwanted means that material is not used. Okay, that is called unwanted material. Okay. In order to obtain these useful substances, chemists often have to separate them from the impurities. The unwanted material is called impurities. Okay. The choice of a particular method to separate components of a mixture will depend on the properties of components. Okay. In a mixture have many components. So that components properties depend on the mixture separations. Okay. As well as their physical state and physical state. Okay. Sublimation. First method, sublimation. Certain salt substances when heated change directly from solid to gaseous state without attaining liquid state. Okay. Listen. What is meant by sublimation? Already you read 7th standard, I think. What is meant by sublimation? Okay, sublimation means, listen, first you know the state of solid state, liquid state and gaseous state. Yes, okay, physical state of matter, solid state, liquid state and gaseous state. Okay, so now the solid state substances are heat. The symbol is mention the heat. Okay, heat symbol. Okay, so the solid is heated. The solid goes to directly gaseous state. What state? Gaseous state. So this is called sublimation. Listen. Solid substances are heated. The solid substances did not change liquid state. It directly changed to gaseous state. That is called sublimation. That is called sublimation. Okay. The vapors when cooled give back the solid substance. That vapor, the gaseous vapor are cooled. Then the substance will come solid state. Okay. This process is known as sublimation. Okay. Examples: iodine, camphor, ammonium chloride. These are the materials are heated to change solid state to gaseous state. Iodine, camphor, ammonium chloride. Okay. Okay. Give the one examples. Okay. Sublimation examples. Okay. Listen. First you see this picture. First this part is called. Listen. This part is called cotton plug. Okay. Here have cotton. So the funnel is covered with cotton plug and the inverted funnel. The funnel name is inverted funnel. So the funnel is covered with cotton plug. Okay. Then solidified ammonium chloride and vapors of ammonium chloride. Then China dish. Okay. China dish and ammonium chloride, salt and sand. Here burner. Okay. Now the procedure is you take one China dish. Okay. Here have the China dish. No. This is a China dish. Okay. This like dish. This like dish. Okay. This is called China dish. Okay. You take first one China dish. Then you add ammonium chloride salt. Okay. Ammonium chloride salt and sand. You take the two mixtures. Okay. Two mixtures. What are the two components? Ammonium chloride and sand. You take this China dish. Okay. You take ammonium chloride NH4Cl. Then sand. Okay. You take this China dish. Then you covered with inverted funnel. You covered with this inverted funnel. Okay. Then you use the cotton. You plug this hole. You use the cotton. You plug this hole. Okay. Now you heat the China dish. Okay, here one burner. No, yes, this burner. You use this burner, heat these things. Okay, so the ammonium chloride and sand are heated. The vapor of ammonium chloride. The vapor of ammonium chloride. The vapor of the here have the vapor of ammonium chloride. Okay, here have the vapor of ammonium chloride. Then the ammonium chloride vapor are deposited here. That is called ammonium chloride. Solidified ammonium chloride. The ammonium chloride are vaporized here. Here the vapor. Here it changed to solid state. Okay, solid ammonium chloride. Okay, listen. You see this. The powdered mixture of ammonium chloride and sand is taken in a China dish and covered with a curved ashtop sheet. Okay, ashtop sheet, this sheet. Okay. Then an inverted funnel is placed over the ashtop sheet shown in the figure. This figure. The open with the steam funnel is closed using cotton wool and China dish is heated. The pure vapors are volatile solid pass through the holes upstairs sheet and contents on the inner sides of the funnel. The non-volatile impurities remain in the China dish. Okay. Here ammonium chloride and sand. Sand is deposited in the China dish. The ammonium chloride is evaporated. Here the solidified the ammonium chloride. Okay. This is called sublimation reactions. Okay. More to know, you see this. The air fresheners are used in toilets The solid slowly sublimes and releases the pleasant smell in the toilet over a certain period of time. Yes or no? Yes, okay. Mothballs made up of naphthalene ball. You see the naphthalene ball? Yes, naphthalene ball means pocha urund appdin solluvoம்ல அதான். Okay. The naphthalene ball, mothballs made up of naphthalene are used to drive away moths and some other insects. Okay. Then these also sublime over time compound. It's a substance used in a Indian household. Okay. It sublimes to give a pleasant smell and is sometimes used for a freshener. Okay. Yes. Okay. You use the naphthalene ball in your home. Yes. Okay. Okay. Listen and listen. Next one. Listen. Methods of separating substances from mixtures. Okay. Types of mixtures. How many types of mixtures? Homogeneous and heterogeneous. Okay. Mixtures. Methods of separation. How to separate the methods. Okay. In a heterogeneous mixtures, you see the component visible. Okay. So solid and solid. Hand picking, sieving, winnowing, magnetic separation, sublimation. Okay. These are the methods are used to separate the mixtures of solid and solid. Okay. Then insoluble solid and liquid. Insoluble solid and liquid. Sedimentation and decondensation. Loading. Filtration. Centrifugation. These are the methods are used to separate the heterogeneous mixtures of insoluble solid and liquid. Okay. Then third one, two immiscible liquids. Decondensation and solvent extraction. These two methods are used to separate the mixtures of heterogeneous to immiscible liquids. Okay. Then homogeneous means you didn't see the components with your naked eye. That is called homogeneous mixtures. Okay. Listen. Soluble solid and liquid. What method used? Evaporation method, distillation method, crystallization method. Okay. Then two miscible liquids. Fractional distillation. Then solution of two or more solids in a liquid. Chromatography. These are the methods are used to separate the homogeneous and heterogeneous mixtures are separated. Okay. So today we discuss what are the types of mixtures. What is homogeneous mixtures? What is heterogeneous mixtures? Okay. Then what is sublimation? These are the things we discussed in this class. Next class we see the methods. Centrifugation method, solvent extraction method, simple distillation method, chromatography method. These are the methods we discussed in next class. Okay. Now your homework is you listen 2 more question. Listen ma, 2 more question. What is mean by homogeneous mixture? And second question, what is meant by heterogeneous mixtures? Okay. Next, what is meant by sublimation? Give one example. This example. Okay. Sublimation example. Then next one, what are the methods of separating substances from mixtures? Okay. So this tabular column you read and write. Okay. Thank you children. Thank you.